All right, for this problem, we're now going to continue looking at the probabilities of compound events. So we have two things happening. You have a certain blood type, and your friend who is going to give you that blood transfusion also has a different blood type. So we want to find out the probability of this event. So one way to help is to make an area model. All right, so we're going to make a generic area model to represent these different events. So we have somebody who's donating blood, the donor, and they could either have A blood, let's start with O blood, 45%, or they could have, so that's O blood, or they could have A blood, which would be 40%, B blood, which is 11%, or AB blood, which is only 4%. So this is your friend who is giving you the blood transfusion, and then you're the receiver. So you could have O blood, 45%, A blood, 40%, B blood, 11%, or AB blood, 4%. Okay, so even though there are 16 boxes, each of them are not the same likelihood, because look, 40% of the population has O blood. So when we multiply those, let's turn that into a decimal, 81 divided by 400, we get 20%, so 20.25, 20.25%. All right, so to find all the different probabilities, all you're gonna do is multiply, and you can write your answer as a fraction, decimal, or percent. Remember, probability is always between 0 and 1, and when we're making these area models, if we add all of these probabilities up together, they should equal 1. All right, so I went ahead and multiplied all the probabilities and wrote them all as percentages. So you can see here, even though there's 16 boxes, and at first it looks like the probability of each is 1/16, because 45% of the population has O blood, 20% of the time, we're gonna have both O and O. And since only 4% of the population has AB blood, the chances of both of them having AB blood is very small. So now it says in part B, what is the probability that you and your best friend have the same blood type? So same blood type. To find the probability for that, you would add up all the diagonals, right? The OO, the AA, the BB, and the AB. So go ahead and add those up. That will give you the probability of the same blood type. Now, in C it says, luckily, two people don't have to have the same blood type. O can donate to anybody. That's because they're often referred to as the universal donor. So if the donor has O blood, they can give to anybody. So all of these would work. Then A can give to not only A, but AB as well. So A can give to A and AB. B can give to B and AB. All right, so now to find the probability for part C, you're going to add up all of those ones that we circled in green.